Okay, we're back. We are going to look at examples of some indefinite integrals. So I'm going to just slide the page up and we're going to run with this. So remember, this is Calculus Jeopardy. These are the answers. What were the questions? It's just undoing those derivatives. And if you want to, you could put that 20 in the front like what we have here. I'm going to just leave it inside though. Okay. And I look at that and so I know the 20 is still going to be around. But, okay. What has a derivative of sine? Oh, cosine. Sort of. Oh wait, the derivative of cosine is negative sine. So if I have a negative cosine, and I'm actually going to put it in front with a little space because I'm going to have a coefficient here. So I have a negative cosine because the derivative of cosine is sine, so the derivative of negative cosine, you're just undoing things, right? Insides never change, so that 9x stays the same. Now, if I were to derive this guy, I would have, with the negative there, I would end up with positive sine, so that's good. But I need a 20, so I'm going to put a 20. But if I derive this, I have that because of the chain rule, that times 9. So that 20 needs to go over a 9. And then r plus c. And on all of these, remember, check your answer by deriving. I'm not going to show that for the sake of time, but if you take these derivatives, and in terms of notation, having it like that just written right below it is totally fine. You can also throw an equal sign. So you're just saying like that top line equals the next line. Okay. So I know the derivative of e to the stuff is e to the stuff, right? So, and I know insides don't change, so I have this e to the negative 0.01x. Now, if I take the derivative of this, notice I didn't touch the 2 yet. I want it times 2 there, so actually I'm going to put it down. Now, if I were to derive this, though, I would have times negative 0.01 show up because of the derivative of the inside. So if I divide by that negative 0.01, I have like the counteracting of multiplying when I derive that, when I check my answer. Could I clean this up and make it prettier? Yeah. Do I need to? No. And in fact, it's faster not to. So I'm just going to have my plus c. So like, remember when we check our answers though, like I have that 2 over negative 0.01 and then times e to the negative 0.01x times the derivative of the inside, so negative 0.01. Those guys cancel out. So yes, my answer is the same. So this is the check. It's not the answer. So it's not a bad thing to do. But if you do check your answer and have it written on the page, especially when you have different colors, it's a good idea to do something like that. Throw a box around it, just so you have like a clear, like this is my answer. Okay. What has a derivative of 7 to the x? Sort of 7 to the x. This is like this guy right here, the b to the x, or b to the u. So 7 to the x divided by natural log 7 plus c, because if I were to derive that, I would have my 7 to the x natural log 7, and then when you have the divide by natural log 7, you're ending up back to where you started. Okay. Notice there's a p here. Does that matter? Nope. You just want to use the same letters that are there. Just obviously keep things consistent. Okay. So I'm going to add 1 to my exponent. I also know insides don't change, so I have my same inside, new exponent, 6. I have a divide by the new exponent, or throw a 1/6 in front. Now, if I derive this, I'll have times 3 show up because of derivative of the inside. So I would have a times 3 show up. I don't want times 3 to show up, so if I do a times 1/3, it counteracts my chain rule, essentially. And then plus c. So I could make that prettier and call it a 1/18. Do I need to? No. Can I check my answer by deriving this? Yeah. Okay, 1 more. Well, actually 3 more. So cosine a to the 8th times sine of a dA. What? Okay. That is actually this guy right here. Like, I essentially have an inside, my u. And then that sine a is my du. So really, this, or sine a dA is essentially the du part. So this is kind of the u, this whole thing here is the du. So it's essentially like a u to the 8th du. Almost, because this needs to be negative. To make this work, and I'm allowed to do this because it's not changing things. If, say I throw a negative to the front, and I also make this a times negative sign. So if I have negative times negative, positive, so I didn't change it. So now this part underlined here is my du. So here's my u to the 8th. So it's going to be 1/9 my u to the 9th. So instead of a u, though, it's that cosine of a. I have that negative in the front, just kind of tagging along. And that's my du. It's gone because that's what would pop up with my chain rule. So this is super trippy and makes your head explode a little bit. But if you derive this by, and check your answer, yes, you exactly end up with the original equation or the original integral that we had started with. Okay. Next one here. Remember, if you have stuff I can speak, separated by pluses or minuses, just deal with them individually. It's no big deal. So my x squared becomes a 1/3 x cubed. My minus 3x becomes a minus 3 over my new exponent of 2x squared, and a 5x, because the derivative of 5x is the 5, and a plus c. Whew, this is crazy stuff, isn't it? This is something that starts out like really, really challenging, and it will always be pretty challenging, to be honest, but it gets better with practice, and practice you will have. I promise that. There's going to be a lot of assignments that seem pretty long because it's just giving you loads of practice to get you faster and more efficient, and you just do a ton of these. It's kind of soothing almost. There's something comfortable about just kind of chunking your way through a bunch of like math problems that have no context. I don't know. Some people really enjoy it. I find it, I don't know. It's okay. Okay. So this guy right here, so look for the insides. When you're doing these, you want to look for the insides. Oh wait, here's my inside. And so here's that e to the, here's that like the e to the u. And then this guy, that's the du part of it. That's the differential, the derivative of the inside, essentially. Because remember, this is basically like if you had the chain rule truck come barreling through, and now you have to clean up the mess and put things back. It's a bizarre analogy. I apologize. Okay, so e to the insides never change, right? And then plus c. Whoa. This is a weird thing. When you're doing a derivative, your answers tend to look more complicated. When you're doing an antiderivative, your answers tend to look simpler. Not always, but usually. And remember always, check your answer by finding the derivative. So here's a few examples. Take a look at our textbook for some more. Remember, read through those pages because those examples are super helpful. And there are our indefinite integrals.